Here's the guide for factoring polynomials. We need to start with the common monomial factoring. Then whatever will be the result, we're going to categorize them as to whether the result is a binomial, trinomial, or multinomial, and we have specific processes under specific results. Then we end it. Let's start with this polynomial. Since this is a binomial expression and the terms are separated by subtraction, we're going to either consider this as a difference because of the subtraction, okay? Difference of two squares or difference of two cubes. But if we're going to look closely at the terms, 8 is neither a perfect square nor a perfect cube, as well as 50, as well as the literal coefficients. For the first term, k cubed, it might be a perfect cube, but m squared is not. M squared might be a perfect square, but k cubed has a portion, but the entirety is not. And k is neither a perfect cube or a perfect square. This would mean we cannot proceed with the factoring of this. But based on our guide earlier, the first step of factoring polynomials is the consideration of the common monomial factoring, or looking for the greatest common factor. If we could locate or factor this binomial with its greatest common factor, and then the result later could still be factored out, then we use whatever methods. Probably it's either difference of two squares or difference of two cubes, depending on our result. So again, we will start with the common monomial factoring. Do not just simply declare, it's non-factorable, the answer is as it is, because you are tasked to factor. So you will start with common monomial factoring. Common monomial factoring talks about the greatest common factor for both numerical and literal coefficients. For the numerical coefficients, 8 and 50, we know that the greatest common factor to that is 2. Okay? Because when you divide 8 by 2, it will be 4, and 50 by 2, 25, and both 4 and 25, aside from 1, has no other factors. So we have 2 for our numerical coefficient. As mentioned, we have 4 and 25 later, but let's write it a little bit later after we are done with our literal coefficients. For our literal coefficients, simply look at the common variables. Here we have m squared, or 2m's, but the second term doesn't have an m, so let's focus on k. The first term has k cubed, the second term has k. So the common factor here is just simply k, not k cubed, it's k, because k cubed can be written as k squared times k. So we have k there, but k cubed cannot be because our second term only has k. Now 2k is the common factor for both terms here, and we have the remaining binomial after we took out 2k. So we mentioned earlier that for 8 it will become 4 because 8 divided by 2 is 4, and then for the second term is 25 because that's 50 divided by 2. Second, for our numerical coefficient, okay, we remove k here, so we are still left with k squared, and since we don't factor, or we did not factor m, it's still m squared here. That's for the first term. The operation is the subtraction, we'll do it like that. But for the second term, after dividing 50 by 2 to get 25, the singular k here was already taken out as the common factor, so it stays as 25. Now from this, some of you might say this is the final answer, but when you look closely at this result here, you would see that this now fits the criteria of difference of two squares. Squares, why? Why not cube? Because when you look at the terms, 4 is a perfect square. k squared, m squared, both of them has even exponents. They are both perfect square. 25 is also a perfect square. So we can proceed here again using the difference of two squares. So the next step, 2k is still here. Don't remove 2k, because if you're going to remove that, you are changing the entire expression. And when you factor out difference of two squares, you have two binomial expressions with separate or different rather separating operations to two terms. Of course, you could make this plus and minus. Nevertheless, these are all factors, and multiplication is commutative, so it could be better as well, like this, or again plus minus, it doesn't matter. Now we are going to for difference of two squares, we have this first step. Again, two binomials with different operations separating the two terms. And the mentioned terms are just results of taking the roots, or specifically square roots, of the first and second term. The square root of the first term, square root of 4, is 2. Square root of k squared is k. Square root of m squared is m. So we have 2 km, not 2 kilometers, okay? We are not talking about units here, but for variables, 2 km. The same thing here as well, 2 km. But here plus, earlier it was minus. Now for the second term, take the square root of that. We have 5. And here you also have 5. So with this, all of this, including the 2k, are your factors for this given binomial expression, because the task here is factor completely or look for the factors for all. And this will not be possible without the common factor 2k, because as mentioned earlier, without removing 2k for both terms, we cannot say it's a difference of two squares, nor other types of factoring processes that we could do with here. So this is the result for this polynomial. The next factor we're looking for is for our next subscriber. Subscribe now!